You are welcome to today's session. Today we are going to be looking at indexes. We're going to be introducing the topic indexes, and my name is Evans. You already know me, and I'm a senior database administrator. So I'm going to be, taking you through this introduction to indexes. Okay. Prior to going into my main topic, which is indexes, it is better to have a background of what we're going to be talking about. And as you know, indexes is a very important factor when it comes to retrieving data from your SQL server. But then let's just take a little background on why we need to focus on index. Talking about SQL Server performance tuning, you want to ask yourself, what is performance tuning? I mean, performance tuning is simply, an improvement of system performance, typically computer systems, and making sure that your SQL Server is working, in its full capacity optimally. All right. Database tuning is the activity of making your database application run more quickly. When I say more quickly, how fast is it for users to get responses when they query your database? This brings me to what we call SQL tuning. So SQL Server tuning is a process of ensuring that your SQL statement, any SQL statement that application would issue, will run in the fastest possible time. That is so important. Now, take a look at this. Every time you have a user, or say a client workstation, querying an application, all right, this application would be sending some queries to your SQL Server, and as you know, your database is inside your SQL Server, where your table is, and writing all those DML statements. Any transaction you are doing, say you are online shopping on Facebook, buying things from Amazon, you are the user. Of course, you can either use your app, your phone, or your client workstation. And what do? You send a request via your application. Now that request is writing some queries to your database that is sitting in your server. And depending on what the performance of the SQL Server in generally, your data or whatever you are querying, let's say, for example, you want to check the balance of your account. You have, just done a little transaction, and it is taking too long for you to see the result of what you queried. All right. When the user, sends this request and the data returns slowly, there could be so many reasons, that can cause this retrieval processes to be slow, which is what we call performance issues. So what we're going to be looking at, why is this data being returned slowly? I mean, there could be so many reasons. Was the application misconfigured? I mean, was there improper setup? Was the application not updated? Do you have sufficient physical hardware? When you're talking about hardware, you mean the memory, the disk, the CPU, and the network interface card. I mean, these 4 components is very, very important when it comes to how your SQL Server performs. Is the query optimizer not choosing the best plan? As you go further into performance tuning, one of the tutors or whoever is going to take this further would be able to explain in details what query optimizer or what it does. But just to give it a high level overview, SQL Server make use of what we call statistics. And of course, this would help the query optimizer based on how updated your indexes are. Depending on what we're going to be saying, is your statistics up to date? This will help SQL Server to generate an optimal, execution plan for your query to take, we would go further into that. For now, just understanding that, okay, it's just like you're going somewhere, you just put in your address in a Google map, and then it shows you the direction of how you're going to get to your destination. So there's something inside that phone, whatever. So in the case of SQL Server, it's called the Query Optimizer, that can show you the flow chart, on how you're going to get from your source to your destination. In other words, how you're going to query your data and what is it going to take to display your result for you. All right, so are the queries improperly written? At times this could be as a result of poorly written query. Do you have proper indexing? As you can see, that is highlighted because that is what we're going to be looking at. Improper indexing on tables, unused indexing, or too many indexes can cause your data retrieval process to be slow, as you would see today. Now, what are the tools and application for SQL Server DBA to use, for performance tuning? There are quite a number of tools, but let me introduce you to some. We have Performance Monitor, we have Activity Monitor, we have SQL Server Profiler, we have extended events, and there are dynamic management views and database console commands, or what we call DBCC commands. There's a couple of stored procedures that you can also use to monitor your performances. There's SQL Server standard report that you can generate, and there's a beautiful feature called Database Tuning Advisor, and as well as execution plan. And just to name a few, we have Query Store that was introduced in 2016. And of course, there are other third-party monitoring tools that you can use to monitor the performance of your SQL Server. Just to mention a few, we have Redgate, we have Foglight, we have SQL Sentry. Of course, that was bought by SolarWinds. I mean, these are just a few that you can do more research on to see how you can use this to tune your query, or for performance tuning. Now, there are many aspects of SQL Server performance tuning, as you can see. We have different things here. We have the DTA, that's Data Tuning Advisor. We have blocking, deadlocking, statistics, page splitting, SP recompile, workload. There are so many things that will be coming to mind as we progress. But what we are focusing on today is indexes as one of the things that can cause you to have performance issues. What is the role of index in performance? I mean, we're going to be looking at what is indexing. What are the types of indexes? I mean, there are a couple of indexes. We have clustered index, we have non-clustered index, we have covered indexes, we have cluster indexes, and included indexes, just to mention a few. But as we progress, this is just telling you the type of indexes that we have, but we're not going to be focusing on all these indexes here, as this is an introduction to indexing. We will just be focusing on the first two most common indexes, which is clustered index and non-clustered indexes. All right. So this is just a continuation of what we're going to be looking at. We're going to look at some demo of indexes. We're going to look at the B tree structure. And of course, in the process of the class, I'm still going to talk about jobs that you can create for your indexes, how the index affects disk space consumption, how your index can be fragmented due to, there's what we call index fragmentation, which we are going to look at as well in the course of the class, and we're going to look at what is a heap. So these are some things that we'll be touching, in the class. All right, so what is an index? An example comes to mind. I just wanted to take a minute or some few seconds to cast your mind back to those days you used to write with exercise book, that you used to read textbook. If you pick up a textbook What do you want to see? You're going to see the table of content. And the table of content has some numbers, some, well, let me just call it pointers. You know that you want to go to a particular topic. Instead of opening the whole page of the book, what do? You just go to a place that is called an index, and you look for the particular topic that you are looking for, and you look at the row number or the page number, beg your pardon, and then immediately you flip. I'm not trying to be religious. I remember there are times in church, when, you sit down beside, some friends, it could be female friends, and, you don't want them to know you're not studying or you don't even know where to go to. And they call, like, they just tell you go to the book of Nahum, and then you don't know where Nahum is because you don't read, very frequently. But somebody who knows where that is, or a smart person, will just go to the index and say, "Oh, it's in page 305." Open page 305, and there you are. In the context of SQL Server, an index, the major purpose of an index is to help you retrieve data faster and efficiently. That's as simple as that. Indexes help you to retrieve data efficiently and faster. How does it do this now? It does this by reducing the number of time you will scan the pages. Think about it again. If you pick up a textbook and you know the topic or you know the page of where you're going, instead of opening from page 1, page 2, page 3, let's say it's a 10 million page textbook. Let's assume there's a textbook that's as big as 10 million. You have to open every page till you get to the 500 page, you'll be tired. Now you can imagine each page has rows and you're looking for a particular information. That means you have to start scanning row by row, 10 million times. You are going to sit down there for like 5 years, trying to get your information. But with the help of index, you can reduce the number of time you visit that page, the number of time you get to your location. You get to retrieve your data. Similar to a phone book. If you look at a phone book, I think I have a diagram of a phone book. Well, let me see here. If I can pull that out and just show you how that works on phone book. Let me see. Okay, yeah, I do have a phone book. Okay, there's a picture. Okay, I'm going to pull this picture in here. Now look at this phone book. Look at this. As you can see this phone book, you see that everybody here has a phone book. So just think about it like, hey, look at this phone book right now. It is in alphabetical order. You can see R, S. That means there's A, B somewhere. So if you're looking for somebody whose name is Stephen, for example, you don't go to the place where A is. You just quickly run to S. And after S, you say Stephen should be S, Stephen should be ST something. You come there quickly, you see his phone number here, 828-118, boom, you call the person. So you see that? So this is an example of what we call a clustered index. As you will see, I will explain that further. This is a clustered index, all right? Because what you just do is that, hey, the data is sorted. Okay, let me ask you guys a question. In how many alphabetical order can you arrange this thing? A, B, C, D, E, F can only be arranged alphabetically in ascending or descending order in one way. So you cannot arrange A, B, C, D, E, F and say A, C, D, E, F, or A, E, D, Z, whatever. So that is not orderly. So this table can be, this phone book can be arranged alphabetically in one order. In other words, you can only have, because of this reason, you can only have one clustered index in a table. All right, because it is only, I don't want to use the word uniquely identifies the record on a table, but stylishly, as we're going to see, you can say it's like that, but you can see here that, hey, Ruth, Robert, whoever you're looking for in your phone is represented in an alphabetical order and is arranged for you, in this way. So this is called a clustered index, as you can see. So that is the reason you can have just one clustered index. I'm just breaking it down in a simple way you can understand. You would see the theory later. So, primarily, I told you already that there are two types of indexes. We have a clustered index and a non-clustered index. All right, so, okay. Now, what is a clustered index? I already told you that a clustered index will sort what we call the data rows in a table or view based on their key value. As such, there can only be one clustered index. Now, when you're talking about key value, remember I showed you, I said, okay, if you're looking at this table, let's just say this is name, let's just say first name, whatever. In the context of what we're doing, a clustered index can help you sort this data based on a key value. Like I gave you that example, that, for example, first name now can be a key value. ID can be a key value. So if you create a clustered index on an ID, because it can only be arranged or sorted in a particular way alphabetically, it automatically creates what we call a primary key. If you create a primary key on a table, it automatically creates a clustered index for you. Now, what is a primary key? A primary key helps you uniquely, insert record to a table. It avoids you entering duplicate records to a table. It uniquely identifies a record on a table. So when you create, let's say, a table that doesn't have any index at all, the moment you create a primary key on that table, it automatically creates a clustered index for you, organizes your data for you. So that brings me to another thing called a heap. Any table that is not organized, that does not have a clustered or a non-clustered index, or doesn't have an index, is called a heap table. Please note that down. It comes in, your first stages of interview where they just ask you, what is a heap table? You just say, oh, a heap table is a table without an index. Okay, so just FYI. Okay, look at this. Because of the way this is sorted, being that you're just creating, when you create a clustered index, you're just creating it based on their key values, it does not require an additional space. But let me give you a little illustration. Now think of still a textbook. Do you know that if you open the back of the textbook, there are still some indexes there that will be explaining the meaning of each word? Let me give you an example. If I say design me a textbook right now, and I said, hey, I just want a table of content and an index in front, maybe a clustered index. How many of you know that the size of that table or of that book will not be as much as a book that will have additional index at the back? In other words, a non-clustered index requires additional space. Why? Because it is not created in what we call the base table. It is created differently from the base table. It requires additional space for you to create non-clustered indexes. So when you are creating non-clustered indexes, be mindful of the fact that be mindful of your disk space, because it does require additional disk space. The more you create non-clustered indexes, the more your space is going. So you have to be careful of that. And of course, it's not all time that index is recommended that you create. Okay, you will get to find out more as you continue to build on your research and study. All right, so let me show you this. Now, when you create an index, whether clustered or non-clustered, all right, anyway, before I get here, let me not go ahead of myself. I still want to see if I can talk more about this index before I go into the architect of an index, with the way an index is, talking about the B structure. I really wanted to talk about, just give you small small, I don't want to jump on this clustered index. Let me just see if I can throw more light on it than that. I mean, yeah. Okay, let's talk about the non-clustered index. I just gave a high level of non-clustered index, but let me talk on non-clustered index. I know it's somewhere down on the slide, but I didn't want to, go into B structure without, but okay, it doesn't make any difference. Sorry about that. Let's just continue. So if you have questions, please write them down. We would answer at the end of the class, okay? All right, so when you create an index, whether clustered or non-clustered, the index is spread across a set of pages. A page is made of, the size of a page is 8 kilobytes, as you would see. I know that one basically, but you would get to find out. Now, whether clustered or non-clustered index, the index is spread across set of pages. Now, I remember I told you pages, and pages always have what? Number. So this is referred to what we call index nodes. We call this the B structure. All right. So the way your index is spread across the set of pages, that gives you the index node that is referred to as the index node. This structure is what is called the B structure. And the B structure of an index is what helps you in retrieving that data faster and more efficient, because that index operates in 3 different levels. All right. Now, your data is actually residing in the index node. What the B structure does is that according to your key value that you are searching, remember, the key value is the column that you are interested in. Is it ID? Is it first name? Is it last name? What column did you build your clustered index on? All right. So now that defines the order into list of, let's say, ranges. It divides that order into list of what we call ranges, the way, as you can see in the on the screen. These ranges are organized in a structure. Now, the root, as you can see here, look at this right here. This is the root node, the root level. This level is defining a broad set of ranges. Let me give you an example. Now, they tell you that, hey, let's just say we write a simple select query and say, hey, give me select, let's say this table, it's, let me just call it ID number. Can you go and select, say this is an employee table, go and select from employee table the student with ID number 77. Because this table have a clustered index, and because of the B structure, which had the root level, the intermediate level, and the leaf level. Remember I told you that the leaf level or your index node is where your actual data resides. Now look at, this has been divided into different ranges because of the B structure. So SQL Server will first of all start to search here. Yes, you're looking for number 77, right? Yes, 77 is between 1 and 200. So it's going to come here, start from here. Okay. Now, is 77, will it fall in this category? No, because 100 is greater than 77. So when your query when you write this query and it's going about what's that, query optimizer, all right, when it's trying to help you fetch your result, it's going to come in here, follow the big structure. You're looking for data for ID number 77. It's not here. It will come here. Yes, it falls in here. 100 to 77 is in here. It will come here. So is it here? No, it's not going to go to this side. It will come straight here. It's still here. And 77, is it here on my left? No, it's not here. So it will definitely just come to the right. You see that? So let's say if this were to be a heap table, a table without, an index, where the moment you search for your data, it's going to come here and start scanning the pages from the root level, go to the intermediate level, is looking for 77, come here, looking for 77, come here, looking for, it's just like somebody is coming to, honestly, I used to hate this. Days when I used to visit the US, and I'll fly Emirates, and Emirates will first of all take me to Dubai and now start doing 20-something hours to America. I used to sleep and wake up and I've not gotten to my destination. Meanwhile, you know, you can just buy one ticket straight boom, to Atlanta, 6 hours. So which query is fast? Which one would you get to your destination faster if you follow an optimal, you know, execution plan? So the same thing here, because of the B structure, it will avoid you from doing what we call an index scan. So the moment you have an index scan is what, remember our first diagram, index scan would cause you to scan. Imagine you are scanning 10 million records. Your data will not be retrieved faster. So what we are looking for is an index seek. And because of your clustered index and the B structure of an index, the moment you hit there, considering the range of the data you're looking for, boom, it jumps. Come here, 1, 2, 3, boom, displays your result, 77. In less than 1 second, it does have a brrr, fetches your result for you. It seeks it, it doesn't scan, it just seeks it. Bam, it knows where it is and goes there, picks your result for you. All right, so this is clustered index. Okay. Oh, look at this. Okay, we already have an example here. Okay, suppose you have a query that says select order ID. Okay, let's say this table, it's sorry, back to that slide. Where is my slide? Yeah. No, sorry. Let me see. Okay, suppose you have a query that, let's say this table is called orders table. I'm trying to bring out the red pointer. I don't know how I did it. Just flew. I pressed my mouse down. Okay, there it is. Good. So to get this, if you're doing your presentation, just FYI, press your mouse down. It's going to show you like this. That's if you have a latest laptop like me. All right. So hope you're having fun like I am having fun. So if, let's say you're selecting from this table is called orders table, and you want to select. Now, I see some things in this query that are very good. Look at this. There's a where clause here. This is a very, very important key. All right. So this is a clustered index, okay? And the clustered index, let's say, was on this order ID, just assuming. So you say select order ID, orders, that's 2 columns from the table columns where order ID is 76. When we execute this query, the root node represents the main entry point. I already explained that. This is the entry point, all right, for queries trying to locate the data via the index from a root node. The data engine negotiates the hierarchy to the appropriate leaf node where the data resides, the index node or the leaf node. All right. The query engine, yes, that was the right words I was looking for when I said query optimizer. The query engine starts at the root node and determines the order ID that is between 1 to 100 or between, like I explained to you. So it comes here. What this is just saying is what I've explained to you. I don't want to waste your time to go through that again. But then let me see. Now from here, it will go to 76 to 100, you know, and then return the data. As this is a clustered index, the leaf node will contain the entire row of data associated with a key value, 76, key value. That's a key point to note. If this is a non-clustered index, the leaf node will point to the clustered table or heap table. Non-clustered index actually points you to where the data is, but for this one, it searches it based on the key value. That's one difference between clustered and non-clustered index. But just for your further research, I want you to, first thing that I want you to research on is the differences between clustered and non-clustered index. Please make sure you submit that. Make sure you do it and submit on Slack. Okay, so now, it says here that, hey, if this is a non-clustered index, okay, the leaf node will point to the clustered index or the heap to be discussed, okay, when we do the next class. I didn't edit that. As you can see, we can navigate the data much faster and read less pages. That is a full table scan. I told you we want to try as much as possible and avoid a table scan. We want to do a table seek or an index seek. We don't have time to be scanning tables. All right, so we're making progress. Now, what is a non-clustered index? I'll try my pointer. Oh, I'm not used to it, but it's okay. So a cluster, what is a non-clustered index? As we can see here, now, remember I told you that a table can have only one clustered index and multiple non-clustered index. Let's assume that you have put a clustered index on your ID, this column. You cannot put your clustered index here again. But let's say, for example, if your query, somewhere in your query says select, from order table where student ID is, or where ID equals to 3, and first name is equal to Mary. Now, there may be so many Marys on your table, okay? Or there may be so many Marys, but since that where clause also has a ID and first name, a proper way you can design this table is to put, let me say, two non-clustered indexes on first name and last name, and put one clustered index here. Remember, I told you that when you create non-clustered index, it's going to create an additional space for you. So consider that when you're creating that. But what that would do is that if somebody is querying this table, don't forget that we already have a clustered index here that has organized our table in one particular order. Let's say if that person is even searching using last name, because there's a non-clustered index in the last name, it may still do a scan, don't forget. But if you use your execution plan, you can find a better way to tweak that query. But a clustered index is a separate structure from your base table. I told you that the other time when you saw that diagram. I told you that it's a separate structure from your base table. Okay? A clustered index is a separate structure from your base table. As you can see, we have a clustered index ID column. We also know that we can't create another clustered index on another column, as it will violate the logic. You can try this on your lab environment. If you have a clustered index, try to create another one, it will throw up an error. We can't both organize column ID of and first name order. No, we can't do that. So how do we create an index on first name or last name? Okay, I already explained that, or age. To get better performance, if the select statement is querying the data where clause is asking to filter Mary. You see that? I already told you. So if you have designed so many clustered indexes, maybe on first name, last name, and age, so even if whatever they query here, it may speed up. Depending on the size of your table, it can speed up because for example, look at here, select first name, last name from student, where first name equals to Mary. This is where non-clustered index play an important part, because you can have many non-clustered indexes. This is because a non-clustered index is not part of your table. It's a separate structure, all right, from the base table. As a result, they are telling you again here that this space become an issue. So we must take consideration that, because it is creating an additional page at the back of your book. Those indexes you used to see at the back of your book, the example of non-clustered indexes. Let me see if I can see one example like that. We're not rushing this because this is just an introduction to clustered and non-clustered indexes. And I hope you're taking notes and following. Okay, let me look for a picture of non-clustered index, and let me just show you. Non-book. Okay, I think I have something to show you. Okay, let me see. Yes, I've seen something. Now look at this. This is it. Let me expand this. This is a non-clustered index, guys. So this is the back of a book. So this is taking an additional space. You can see here they put index. So at the back of your book, it's going to show you, hey, it's also sorted it. Okay, this is also sorted, but look at all of the non-clustered indexes saying, if you're looking for anything that is Presbyterian, what does it do? Now, watch this, guys. Remember I told you that a non-clustered index can point the data that we're looking for resides in this clustered index that is sorted alphabetically. Now, Alexander is on page 29. But if you are searching the non-clustered index, you are looking for anything that starts, okay, let me go to C, because there's no A here. It started from C here. So all these things started from C. Let me say if I'm searching something, good. You see this? Alexander is on page 29. So this is pointing, this non-clustered index is pointing us to page 29 that is on your index. This is the back of the book. If you're looking for, say, anything here, say Presbyterian, all these things, they tell you that, hey, you can see this word Presbyterian in page 11 or page 49. It appears in 2 places or thereabout. So this is what clustered index helps you do. It points, it's actually a pointer to the, it points to the non-clustered index where the remember I said the data is residing at the leaf node in your B structure. So just take, anytime you think of non-clustered index, think of the indexes that is in the back of the book. Okay, so we're making progress. Let me see. Okay, we would soon take a small break, but before then, let's see how far we can go. Now, a non-clustered index contains the index key values. You can say the key values and what? And row locators that point to the storage location of the table data. As discussed, of course, we can have, as we've said earlier, we can have multiple non-clustered indexes on a table or an index view. Now, non-clustered indexes should be designed for frequently used queries. That is why we don't have to, if you do not frequently query a particular, column, say in your environment, when you get to work, developers will always make a particular change there. There's some queries that they would probably be running every month. So those queries would have had some indexes created in them so that they can retrieve data faster and not break and not cause slowness or blocking in the system, or sorry, in the server when they are running their queries. So it is better to design those tables or frequently used, those queries, it is better that they design those frequently used queries very well so that those queries can be targeting and be touching, the clustered and non-clustered indexes. Now, as we can see, a non-clustered index are optimal choice for exact match queries because the index contains the entry describing the exact location of the table, like we just saw in the stuff I just showed you. Now, for an online transactional process, that's an OLTP application and large numbers of index of the table. Anyways, for any DML operation that is happening, it is better that you always have an index in there because all indexes must be adjusted. All right, whenever you're performing indexes, anytime you're inserting, updating, or deleting, or merging statements, querying your table, this can lead to what we call fragmentation, but we are not yet there. This is just telling you that before creating an index, these are the guides, these are things that you should keep in mind. That, of course, you can create multiple non-clustered indexes on columns that are involved in your join and grouping operations. We have done joining when we're doing TSQL, I remember, and we have done group by. So that's what it's just talking about here. Of course, we're reiterating again that you should create a non-clustered index in a column that frequently involves a search condition using where clause. This is an important factor. You must always consider that, using where clause. Okay. So now create a non-clustered index. Okay. Create a non-cluster. What? No, this is wrong. Sorry, guys. I didn't edit this. Create a non-cluster to cover the query. There is what we call covering index. As we would see, when you're covering a query, it means that, hey, this query can have more than one predicate. You can write a query to cover more than one columns, included columns. All right. So the query optimizer can locate all columns values within that index. You know, whenever I use it, SQL Server is so sensitive. The query optimizer is so sensitive to be able to, whenever it's trying to generate your optimal execution plan, to query, to locate all those columns that are included within your index and give you, you know, a very quick and fast result to avoid, you know, a lot of input and output operations. I mean, making your digs not to run for a long time to give you your record. Yeah. So now we should also create non-clustered index on distinct values, such as combination of last name and first name. Okay, like we saw in the example where you can just create a non-clustered index on first name. Let me go up and show you, or first name, last name, or age. I mean, these are these are you know, distinct columns, because even though two people can have the same name, but when you say distinct, you can always distinguish between people, you know, their values are distinct, you know. So, yeah, look at this now. As you can see here, what we have on the right is a non-clustered index. I wish I can bring that red thing again. This is the non-clustered index, okay? By the right, as you can see here, we have the row locator. It's telling you that, hey, first name, Bob. Look at this, it is sorted well. This is a clustered index. So this is not a heap table, because this table has an index and has a number. So this is not a heap table. This is an organized table. So as you can see here, it says, hey, first name, Bob. Bob is also here. It says, hey, what's the row locator? Bob is in the row locator where you can locate Bob is 111. But also see, this is the same person. The last name is here. The row locator is 111. So how would SQL Server go ahead? Don't forget that all the columns in the clustered index have been sorted based on range. So even if this guy starts from row locator number 111, he's going to jump straight to that range where it falls in the clustered index and quickly sort it, go to the leaf node and point your data for you. As you can see, when creating a non-clustered index, we can create more than one index. You can see, we can create one on the last name, we can create one on the first name, but we cannot create two clustered indexes, only one. All right. So this is because non-clustered index is a separate structure. See, this extra space that is needed here is a separate structure from your base table. This improves performance of frequently used query, which are not covered by the clustered index. All right. So as we shall see in the demo, note that when you are creating clustered indexes on columns, this space become an issue. I've told you that before. If you have, say, 1 million rows of first name and you create, let's say, a non-clustered index on first name, then you would also have separate structure of millions of rows with the data, thereby needing more disk space. So these are the things you need to consider. Is it wrong to have too many clustered index, non-clustered indexes? I'll say yes. You shouldn't have too many. But depending on your frequently queried, queried columns. So that can be designed for. Since we're not the developers, we're database administrators, when they send you a query and you tune the query, you look at the query, or they call you and say, hey, performance is slow, can you help us tune this query? You can then look at it and then make your recommendation based on your experience and what you know, that, hey, why don't you create this clustered index? Why don't you create this non-clustered index? I can see that if you do this, it's going to improve this query by so and so. This is the cost of the query. There's what we call cost. When you look at the execution plan, there's an operator called cost, which you would see in the course of the class. So now this is an example of a table that has both a non-clustered index on your left that is sorted by first name, and a clustered index that is sorted based on your ID. Now look at this. The same B3 structure, the root, the intermediate level, and the leaf level of the non-clustered index. So also does the clustered index have the root. So I'm combining both tables now. Remember that this is the row locators I told you guys. Look at the row locator. If you're starting from 200 and you're looking for a data, you're looking for Mary. Our example was Mary. Mary is in, the row locator for Mary is 51. So Mary starts, by the time, don't forget that Mary, if the first name is Mary, just select from this table where first name is Mary. Because you have a non-clustered index that was sorted based on the first name, is going to go straight, follow that same B3 structure. Mary is in 51. 51 is not here, so it's not going to go this way. It will follow your non-clustered index, come this way, comes here. The moment it hits Mary, Mary points straight. Mary is in 51. So it points straight to 51. Where is 51? Mary is in 51, Mary. Okay, so it comes straight here and points to, so Mary would fall here. All right, so Mary can be here. It can't point. This is just an example, just showing that it points straight to the clustered index. So you can see that Mary is in number 51. So the moment it hits here, boom, it points straight to the data and fetches you your result, following the B structure. Let's say if you're looking for anybody that is within the row, say you're looking for somebody that is within 75, the non-clustered index will be so sensitive to know that 75 is here. It comes here straight, boom, and it points you to your data. So that is how non-clustered index and clustered index work hand in hand to help you retrieve data faster and in an efficient way. Wow, we're almost done with my slides. I just have a couple of more to go before we go take a break, then we come and do the demo. Now, in further understanding how your index is working, there's what I'm just going to give you a high-level introduction to what we call execution plan. Whenever you submit a query to SQL Server, no matter how simple or how complex this query is, SQL Server will generate what we call an execution plan for that query. That's how it's going to generate an execution plan, showing you how we are going to carry out the plan, how we are going to execute this query. All right. So it makes use of what we call the query optimizer to generate an optimal execution plan based on what we call statistics. So the execution plan shows you how SQL Server breaks down each query that is submitted by showing you a graphical representation using what we call operators. You would see, I'll show you a picture of an execution plan. Of course, I'll also show you how to see it in your server. There are 3 ways that you can view your execution plan. There's what we call actual execution plan. If you want to run a query and you highlight the query and select your actual execution plan, it's going to show you the road before you start the journey. It's going to show you the plan is created after your execution, before you create that query. If you select the actual execution plan option, the plan is created after you execute the query. All right. If you select, that's the actual, beg your pardon. I was talking to, I mixed it up. Let me give you the estimated execution plan. If you highlight it before you run a query, it is going to show you the estimate. You want to travel from, say you're within, let me say, Richmond in Texas, and you want to go to Sugar Land, you punch in your address. It's going to show you, it's going to take you 20 minutes. Oh, there's traffic here. It's going to show you. Then if you hit start, you're going to see your execution plan, the route you are going to follow. SQL Server works like that too. Okay, if you highlight your query, you write your simple select statement and you highlight it and you hit estimated execution plan, is going to show you how it's going to execute that query, to tell you, hey, if you execute this query, this is how it's going to go, this is how it's going to, graphically, you would see it graphically. But if the actual execution plan, if you select the actual execution plan, that will be generated after you have run the query. Then since 2016, there's what we call live query statistics, which if you select that option, it will show you live how SQL Server is executing that query behind the scene. It's going to show you active query without waiting for it to complete. on the go. You're seeing it live. What are the ways that we can view execution plan? All of these questions I'm going to ask you during the Q&A, so please take note. You can view execution plan, in 3 ways. Graphically, you can view it using the text plans. You can do it using the XML plans. One of the good things about students is whenever you're learning, please make sure you always go back and do your own further research, all right? How does the execution plan select the most efficient plan to execute? That's a good question to ask. It uses the query optimizer. That is what SQL Server used. It used the query optimizer to generate you an execution plan. What is a query optimizer? A query optimizer is part of the SQL Server engine that SQL Server queries and determines what the most efficient plan to give you to use to execute that query. It does this by optimizing each statement, as you can see on the flow chart below. Okay, it does that by optimizing each SQL statement based on statistics. I've been telling you, based on statistics collected about the access, that keyword, access data. Meaning if your index, if your statistics is out of date, if there's fragmentation due to a lot of DML statements, the more you, don't forget that in a live environment, your server will be so busy. People are querying it from everywhere. They are inserting record, they are deleting record, they are updating record. There's a lot of DML operations going on in your server. That is why along the line, when we're doing maintenance plan, there's what we call index optimize. Index optimize is a job that we always create that takes care of fragmentation. Between 5% to 30%, it will reorganize the index. Above that 30%, or say, some people say above 50%, well, depending, it is going to rebuild your index for you and then update statistics. Why? So that your SQL Server can generate an optimal execution plan. The query optimizer can generate an optimal execution plan to retrieve your record faster. All right. So the following diagram shows the steps by which, the query optimizer used to create the execution plan. Look at this. We are doing a simple select statement. We're selecting 3 columns, A, B, and C, from 2 tables or from table X, Y, where A is less than 500 and C, and C, as we can see, C is a character, EFG, because of this parenthesis. Now, the query optimizer will pass your statement, will validate the statement, run through what we call a system catalog, optimize that statement. It's doing this behind the scene. Generate your access plan, boom, then shows you the execution plan. Now, based on the healthiness of your index, based on the healthiness of your statistics, this is what I can give you. Imagine if your phone doesn't have network and you go and put GPS, it will be showing you blue. You will not know that there's traffic there. The moment you have an internet on that phone, boom, it generates an optimal execution plan for you. And you see traffic. A place of 30 minutes will be showing you 1 hour. So you must always update statistics, to make sure that the query optimizer uses the best execution plan to generate your query, to execute your query, beg your pardon. Now, inside your execution plan, there are different operators, that I want to talk about. This link, I'm going to share this link with you, or when you get the notes for the class, you're going to see this or the slide. I mean, you can always get this link. So these are some operators that we would be looking at, or that you need to probably do some more research on. Table scan, what is table scan? What is clustered index scan? What is clustered index seek? What is non-clustered index seek? What is compute scalar? I mean, we have so many of them. We have, just so many of them that we can touch. What is key lookup? What's RID lookup? What is a sort? What's a filter? I mean, I would just throw that to you that, hey, go do some more research on it. I mean, it's very easy to get those details out there, but you learn driving by sitting on the driver's side after you have been shown how to drive. You take the driving seat and you start driving the car. All right. So make sure you do some little work on your end. But what we will do here is to, this is just an introduction. So as we continue to progress, we'll be deep diving more into some of these operators that can cause serious, that when you see them on your execution plan, you should know what they are doing and know how to, use them to tune your query, to give you, to make your SQL Server retrieve data faster to solve your performance issues. How do you read your execution plan? You can read the execution plan either from right to left or from left to right. When reading your execution plan, you're asking what are the commands that you want to use to get the data. I mean, when reading from right to left, you're asking what is the flow of the data. Of course, the thickness of the arrow shows the count of rows that you can. I mean, this is just something that you can try. When you see the execution plan, you can just place your mouse on the arrow and you see the thickness, that they are not the same and all of that. So this is how execution plan looks like. Sorry, let me bring it here again. Execution plan, this is how it looks like. So you see now. So this part, I told you can view execution plan in 3 ways. This one was actually generated using what we call live query statistics. So it's showing you how SQL Server, the query optimizer, have generated this to show you this was a select statement. Look at this select statement. Select top 1,000 departments, whatever. So this is how SQL Server is executing it. You can either read it from left to right, or you can read it from right to left. As we can see here, this is doing a clustered index scan, which is an expensive, and you see the costs. These are operators. So you would want to look at why is it doing a clustered index scan. Now, from my understanding, for you to see this, that means there's a clustered index already on this table because it's showing you that it's clustered. So just because you have a clustered index does not mean you cannot be having a scan, which is a bad experience. We always want to look for sick. Well, depending on the size and volume of your table again, some small table, I mean, how many things you want? If it's a table that is less than 20 records, I can scan it in less than 2 minutes. But if you're talking about 10 million records, then that is a poor thing to have, So from this means whatever they are selecting from this person.person table, there's a clustered index, but there's no non-clustered index on that row on that column that is being retrieved. If that where clause is saying, what I can, okay, let me see here. And SQL Server 2 can also recommend, which I'll show you during the demo, to say, hey, go and create a non-clustered index and we'll suggest columns for you. The moment you add 1 or 2 of those columns I suggesting, based on the query that you're running, and you try and you see your execution plan again, either actual estimated or live query statistics, is going to show you what it's going to do. Is it going to scan or is it going to seek? Look at here, there's a merge join here. Now another clustered index scan. The cost is about 100%. And then we have a hatch match, from this select statement. So all of these are operators that I told you to go find out about. All right, so we're going to take a break. And when we do a break, we'll come and do demo. For today's demo, I'll be showing you the importance of having an index. We're going to see a heap table, and we're going to write some queries against a heap table, and you're going to see how fast it retrieved how fast it was able to retrieve data, and how slow it was able to retrieve data. And we're going to create an index. I'll show you the query to create an index, and then we're going to see how it's going to retrieve data, and we're going to compare and see. Remember today's introduction to index. The importance of an index is to help you retrieve data faster and more efficient. So see you Just get up of your seat right now, take a break, go drink some water, and then we'll come back to continue, the demo. All right, welcome back from your break. So we're talking about indexes, and we said the purpose of an index is to help us retrieve data faster and more efficiently. And we said there are different types of indexes, but what we are focusing on is clustered and non-clustered index. We also did say that a table without an index, be it clustered or non-clustered, is referred to a heap table. That means the data is not sorted anyhow. And talking about the heap table, just because the data is not sorted, anytime you insert a record on a heap table, it goes to the end of that record. It doesn't sort it automatically to go to the end and insert your record for you. So we'll quickly go into demo. I'm going to create a simple database, call it index database. I mean, create an index is easy. You can either use the GUI or TSQL. Index DB. You can see. Anyway, because this is a demo class, and it's not about talking about creating database. I believe that has been handled, talking about AutoGrid and what have you. So I always like scripting mine out. So if you hit OK, please, for the purpose of this class, I want to just let you know that my data drive is on my E drive and my log is on my F. So if you're doing your demo, make sure you use your file explorer to locate. Your file explorer is this yellow envelope. It's called File Explorer by my left. My mouse is right here to locate where your data and your log is. If not so, you may be having some errors. So I've actually scripted it out here. So I'm just going to pass it and then I'll create. Okay, so IndexDB already exists. All right, so I'm going to drop it. Close existing connection, drop that. When people see error, they are always, I love seeing errors because without errors, you can't actually know what to do. And just to issue a disclaimer, this is a lab environment. Anything can go wrong. So the demo may not go as planned, but just understand the concept. So even if we see errors or something, I'm going to try, but I don't want to do a live troubleshooting on this live class. As you know, we're working with time. So, all right, now that I've done that, all right, the connection is broken. So it's reconnecting here. You may not experience that issue. I don't know. I'm having issue with connecting, but anyway, while that one is doing, let me create my thing. Index TV. Okay, while it's still passing, we have created our table. Good, we have created our index, so I don't need this guy again, but the query is to let you give them know. I'm going to stop it there. Canceling this query. Okay, so anyways, so now I have created my index DB. As you can see, before we continue, the name of the database is index. An index is always residing inside a table. If you click this ellipsis button, right now, there is no index here because there is no table. So what we are going to do is we're going to use this index, this database that we've created, index DB, we're going to create a table. So before then, sorry, I was working on my SQL O2. So I want to change this SQL O2. So I'm going to say Control H. Control H is going to open as everywhere in my script that I have SQL O2. I want to edit it. So Control H will open this for me. And I'll call it index DB since I'm working with index DB. And you say find all. So it's going to replace 10. Okay, in 10 places. Good. Okay, so that is done. So I'm going to use that index. All right. Use that database we just created. Go create a table. You can use the GUI, but T-SQL is faster. The default schema we're using is DBO. The name of the table we are creating is phone book, and we say give us 4 columns. As you can see, there is no clustered index here. We're just creating, a normal table. If you refresh this table right now, you are going to see dba.phonebook. If you open it right now, you'll see index here. So this is a heap table. Though there's no data, this is a heap table. It does not have a clustered or non-clustered index. So this is a heap table. Any data you enter in here is not going to be sorted. So there are different databases you can use. You can use AdventureWorks but I have an app called Redgate app. I'm going to populate 1,000 records from it. I can save the database. And with the tables and then send it to you, and you can restore it like you restore AdventureWorks. Okay, so I can use, this is my app here. You may not have it, so don't worry. So I can either do it here, or I can come to the table, to the database, right click. It will tell me populate IndexedDB with data. So it's going to open the app for me. It's called SQL Data Generator. Oh, I have one open here already, okay? So it's going to connect. Okay, now I already signed in. Close this guy. Okay, I know I already have it. It's going to do that. So it's generating for me. Okay, it's creating a project. So this is how it works. You see it here. The table we created is phone book, and it had 4 columns, as you can see. All right, it has connected to my server. Look at it, this is my server. This is the database. So it's just a tool by Redgate to generate data. Now I want to do 1,000 records. Okay, so I'm going to come right here. First name, I want to see the way this is designed. Last name, I don't like the way this is sorted, so I'm going to come here. I don't want numbers, I only want letters, text. Okay, first name. Okay, I'm going to come to first name. I want it to be able to give me just text, not then phone number. Let me see the way this phone number is sorted. Okay, yeah, phone number is good. So we're going to say, okay, good. So everything looks good. Click the phone book. It's going to say, hey, 1,000. So what it's doing is it's going to generate, the moment we generate, okay, it's telling you this, good. So it's going to generate data for us straight up and populate that table. Okay. All right, it's done. Good. So I now have, this is the report is successful. So I now have my 1,000 record. Okay, I minimize that. Now, let me just run a simple select here. As you can see, now we have our data. If you look at the row here, it has 1,000 rows. If you look at the right column here, good. So now we've populated our data. Oh no, there are some null values. Phone book. This is not going to work because I didn't want. If you want to put primary key, there's supposed not to accept null values. Okay. Sorry, let me repopulate that guy again. Is this it? Phone book ID, integer no. Okay, the way I designed the table, I put no. Okay, good. I can always drop the table. Anyways, so good. So we have our table now. We've inserted 1,000 record. We can select from it to view it. We've done that already. So now to show you that any table that is, you look at this now, it is not sorted anyhow. Look at this. We have S, last name is not sorted. So right now, this is what is called a heap table. The data are not sorted. So this is a heap table. If you insert this record, is because it's a heap table, and you select, it is going to go to the bottom of the, it is going to go to the end of the record. Okay, if you look at this now, insert into this, it's going to go to the 1100 row. How do we find that out? Let's see. Let me see, select start from this. Let me just show you that the 1000. Let me just use a simple order by, let me just say last name in descending order. Let's see, I want to show you the last record that's entered in this. So anyway, because it's not sorted, so it's not going to give me, so the last record is this guy. But right now, because it's a heap table, the 1001 record that's entered would be this guy, would be Abba. So how do I know? I can just say where last name is Abba. Where last name is Abba. It's Abba. Though, let me just say, I just want to show you that the last record that entered there is Abba. Abba, sorry, not Anna, Abba. Let's see so you see this, it's showing us 1001 record because it went to, because of this where clause. So the last record that entered is 1001. So now let me put the next record again into that table. You see that it's going to give us 1002. Good, one row is affected. So if I say, hey, where last name is equal to Turner, if I put Turner, you're going to see it's going to show us the row call. This thing is going to be 1002. Look at that, 1002. So this table is not sorted. So as you continue to enter data on a heap table, it will be taken it to the end of the table. All right, it will be taken it to the end of the table. So now we're going to create a clustered index on table phone book. All right, and column last name, so that the last name is alphabetized, is sorted, and the clustered index is created. So now this is a command to create a clustered index. You're going to say, use the name of your database, create clustered index, the name of your index. If you look at now, this is the name of our phone book, and the name of our index, we want to put a clustered index on our last name. That means our key value, the column we want to search, remember from our explanation, is going to be on tuner. So we want this table now to organize itself. All right. But before then, anyways, I'm showing, okay, I'll show you some things again. And let me just finish this demo. I don't want to go ahead of myself. So now we're going to create this index. All right, so we create this index, execute. If you come now to the table, you refresh this index. So it's no longer a heap table because it has what? A clustered index. And you see it there. So now a clustered index has been created. So now let us see now. You will notice that the last name would have been sorted. All right. And everything would have been in order now. Look at that. Because of this null value, honestly, I would have said, don't accept null when I'm designing my table. I would have said not null so that you would have seen. But look at this. The data has been sorted. But the phone book ID is not sorted. You see that? Because I didn't put my cluster index was on this particular column. You scroll up here, you would see from my table that I created, phone book ID is the first column. So that's right. So as you can see here, now with the cluster index in place, if we insert any record now, it will automatically, it will not go to the end anymore because you have, remember I said a clustered index, it arranges data based on the key value. And now because you can only sort this data, B can never come before A in a clustered index. A must come before B. That's why I see A, B, A, then you now still go and see B. So if you insert any record now, it will automatically sort itself and enter the right place for you because of the clustered index. So now we're going to insert a record that starts with B, Brigham, but just so you know, to prove to you that Brigham is not yet on this, I'm going to just copy Brigham. You copy Brigham, and let's use a simple query. Say where last name, where, select start from where last name equals to Brigham. All right, let's run this now. You see that it will not show you anything because Brigham is not there, just to prove to you. So now we're inserting Brigham. Don't forget that in the heap table, Brigham would have gone to the end of the row. But right now, Brigham is not going to go to the end of the row anymore. Execute. Brigham, despite the fact that the ID is 1003, but if you do only select star, you will see Brigham has been added in the B column, wherever there is B. So it's going to be BR. So let's look for Brigham. Look at it. You see that? It didn't take Brigham to the end of the record. It sorted her and brought Brigham to where B automatically, because there's a clustered index on the last name. Right. So that is how clustered index works. So now we are progressing. So now we're going to drop that table and we're going to see how non-clustered index work. Okay. So we're going to drop the table phone book. We have dropped that table. If you refresh table right now, you're not going to see it again. It's not there. So we're going to work on non-clustered index. So that is a demo of how to create a simple clustered index. That's how to create it. Okay. I'm just showing you this first part. I've explained heap table and I've shown you how to what a heap table is, a table without clustered index. And if you insert the data into a heap table, it takes the data to the bottom of the row. But the moment you introduce a clustered index based on the key value, it automatically sorts your data. So when you now start inserting, it sorts the data to the right location based on the range, like we saw, because of the B3 structure of a clustered index. All right, so now, so this is what we're going to do. So select star from IndexedDB. Okay, phone book, no. View the data of clustered index. No, we're done with that. It's going to throw up an error. One second, guys. I've deleted that already. So select start from IndexedDB. No, I've done that. So, oh, did I repeat this? I dropped that already. 1 second, guys. Oh, I copied this thing twice, sorry, when I was copying. Okay, I wanted to show you something. Before I go to non-clustered index, we can actually create another clustered indexes, okay? Create another clustered indexes. Okay, good. To show you, remember I told you that a table can only have one clustered index. So let me quickly bring that. I would have adjusted that note. Sorry, guys. Let me quickly create that clustered index again. This is a script. That's why TSQL is fast. No, there's no table. You can't create an index when there is no table. Where's my table? So you're going to have this script to create yours. So good. Created my table, and good. That table is empty. All right, the table is empty. Don't worry about inserting. I just want to show you something. I've created a clustered index. This is one clustered index. Good, he has a clustered index. If you refresh table, you will see my table there. Even though there's no data, go to index, you see clustered index. This is one. Good. So let's go and try to create another clustered index so that you will see that the table cannot have more than one clustered index. So this is another clustered index. I'm trying to put this one on a phone book ID. The other one was on the last name. Look at this. Cannot create more than one clustered index on phone book. Drop that existing. So if you want to create another one, you have to drop this one. You cannot have more than one clustered index on a table. So this is the proof. We're trying to create another clustered index on another column. It's not working. So that's a proof that you cannot have more than one clustered index on a table. So let me drop that index again. Dropped. So I still have my table there. Good. Create a clustered index. Yes, you can create a clustered index, okay, on multiple columns. Yes, you can create a clustered index on multiple columns, but not more than one clustered index. You can create one clustered index, but you use the first name and the last name to sort it. All right, so let us do that now. Look at this. We create this. Right now, if you create this, execute. Good. So it has created that for us. Refresh this guy. Look at now. So the index is on both the first name and the last name. So now let us go and insert data into this. Let's populate. Oh, it's going. I have this thing open. I don't know why I keep going there. Let me come here. Let's populate this table now. I'm going to refresh this guy because this is a new. Remember, we created a new. So refresh the schema. It's going to refresh it. Good. Refreshed it now. Good. So first name. Good. Allow null values. I don't want to allow null values. That was what happened last time. Last name. I don't want to allow null values. I don't want null values. Good. So we are good now. So I'm going to generate another 1,000. Good. It has finished generating a 1,000 record for us. Good. So go back to your server. Now that it has done that, let us select from that phone book. You select. Look at this now. Can you guys see it? Because we created our clustered index on last name and first name. Look at what happened. We created it on last name and first name, so it has automatically. So you can create your clustered index. You cannot have more than one clustered index. However, you can create a clustered index on 2 columns as one. Look at it here. On first name and last name, meaning the data has been sorted on both first name and last name. So this is not a heap table. Look at the moment we insert data, automatically it arranged it for us. If we didn't have this index, if we didn't have this and we insert it, it's going to be a heap table. So now look at the first record on the last name is S. For you to see something, let us insert a record that starts with A and A. You see that it will become number 1. Let me use a simple query here to insert record. So I'm going to insert record. Let me just call it 1,000, and I'm not following the order because it's not a cluster index. So I'm going to call this A run. I did it that way. I put ~3 A so that it will be the first record. Then I'll call this on John. I'll call this on A. Since there's no A here, A John, then I'll change this number to, anyway, they can have, anyway, let me see. I've changed this number to make that record unique. So I just want to, this is a simple insert statement. So I'm going to insert this record now into this table. Watch this, and then we'll run a select statement. You can do both together. Our first record is Aaron Shari, but the moment you execute this, our first record is now AA. Because there's a clustered index on both the last name and the first name, automatically is the number 1 record because it starts by AA. You see, that's the beautiful thing about the index, and it puts the record on top. So that is the beauty of a clustered index on a table. It helps you retrieve data. We have not actually shown the demo of how it can help you retrieve data faster. I'm going to show you that one in a minute. Okay, so while we're doing that, let's go and see how a non-clustered index works. Okay, so now I'm going to drop that index again, and then we create in. Anyway, I'll leave that index, but create clustered index. No, I'm done with this guy. So now we are here now. Non-clustered index. Okay, good. So I'm going to drop this index. Now that we're done with this, I'm going to drop this index. And the moment I drop this index, watch this, guys, it becomes a heap table automatically. I'm dropping that index. it becomes a heap table. If you select now, where's the select statement? Let's say it selects. Oh, because I don't know, maybe because the table has been sorted already. Let me see. I've dropped that index, but anyways, because I put that index there before creating it. Let me see. Okay, we just learned something new. That means if you create a table and you have an index in it before inserting data, even if you drop that index, that data has been sorted already. I was thinking that because we deleted that index, the data should not be sorted anymore, but this is, as you can see from the demo, is not showing so. So what we're going to do now is I'll probably drop that table. Okay. I'll delete the record inside. I can truncate it and then populate it with another data. Okay. Now that is there, because you're not going to appreciate this a lot. So let me just create another table and call it, let me create another table and call it, so you can always scroll up to go create another table, and you can call it phone book 2. So I'm going to create another phone book 2 so that we can use it for our non-clustered index. Good. Refresh this table. Refresh. So we have it there. So now let's go and use table 2, phone book 2, beg your pardon, for our non-clustered index. As you can see, this is, if you open the index, it's it doesn't have anything in there. So we're going to go to our script and run our script to create a non-clustered index. So use IndexedDB, go create this, call it. Anyway, if you leave it that way, to still create it for you, but to avoid confusion, I'll just add 2. So on phone book, yep, first thing. So now create a non-clustered. This is the syntax for creating a non-clustered index. All right. So it says, notice that after creating of a non-clustered index, the data is not sorted. Anyways, I am going to create, right now, there's no data in that table except, okay, let me populate it first. Let me populate it then. In your own, you can use a select into and just put your data there, but since I have what can generate the record for me, refresh this guy. Refresh schema is going to bring 2 tables. I should see phone book 2 now. Good, I've seen phone book 2. So I will select this first one. Is this one I want to work on? So I open it. So I start from the first column. I don't want to see no, don't allow no. Good, that first column, good. Then I go to the second column. I don't want to see no. I don't want to see numbers. I don't want to see numbers. So this is SQL generator. You can download it and just follow the, I don't want to see no too. It helps in generating data. I don't want to see no. Good. So I'm done with this now. Okay, good. Good. So I can go to my home now. Good, I'm done sorting the data. So I can go to my home now. Okay, 1,000. I want to, anyways, for this demo, let me create 10 million because I'm going to use it for some other things. So I'm going to put 10 million record, 10. Or yeah, 10 million is not much. 10, 1, 2, 3, 1, 2, 3. So I'm going to generate a table with 10 million rows, 10 million, good. It's going to take quite a while to generate that, but let's see. So it's generating data for me. And while that is going on, with this particular one, I'm going to now, after I show you that the non-clustered index cannot sort your data for you, I am going to show you how creating an index in a table can help you retrieve data faster and more efficiently. And after that demo, we are going to end this session. So before that is coming, I'm going to send you the script. It will be available. You can run the script. It's quite easy to follow. As you can see, the table is big. 10 million is not small table. So I want you to be able to have large data. So I'm going to copy this this table, 10 million rows, and on this table, I'm going to copy it and save it, and then I can email it to you guys so that you can also restore it like AdventureWorks and do the demo with 10 million records so that you can see how slow it is to retrieve data if it doesn't have an index and if you have an index. So it's generating data into that table for us. It's almost done. So if I did 1,000, it would have been done since. So you do select star, you see some few tables, but let's just be patient. So now we're looking at how to create a non-clustered index. The syntax, again, is just like a clustered index. Use the name of your database, go create non-clustered index, the index name. You see it here, NC stands for non-clustered. Oh yes, I told you I'm going to also show you how to use the GUI. If there is anything you need to know, if you can locate wherever you're being told, whatever you're being told to do, just go there and right-click. So index, as you know, is under the table. So this is a table. When you open it, you see index. If you right-click, it will show you new index. You can come here, you see. You can either create a clustered index here or a non-clustered index here. There's another type of index called non-column store indexes. We're not talking about that today. We're just talking about this too. So if you create here non-clustered index, it will open up a GUI for you. And you can start. Do you want it to be unique? No, this is the name of your index. You can give it whatever name you want to give. You can come here and click on add. The moment you click on add, which column do you want to create your index on? Is it first name? Is it phone book ID? The moment you hit OK, it's going to tell you, okay, I'm going to create it in ascending. I'm going to sort it in ascending order for you. And do I allow no? This should be no. But anyways, by the time you create a clustered index, it cannot accept no values, but I don't know why that is saying. Anyways, if you script it out, you're going to see that same query that we generated. So look at it. Go create clustered index. This is the clustered index on the table. And on what is the name? What's the column you are creating the index on? This is it. So that's just a way of, I'm closing that. Let's see. Okay, good. Our data is done generating, not this guy. Not this one. Also, is done generate. Oh, no. This is generating. Sorry, so many columns are opening. Let me close it now. So, good. Our data, I want to close all these guys so that, good, look at it here. 10 million rows have been inserted. Good, that's what I wanted to see. Good, and I can close this guy. I don't need it anymore. Save changes. I can say no. So if you come here now, look at the table. So now if you refresh on tables, refresh this table, refresh. So it's still a heap table. It doesn't have an index. If you right click, and it says select star. Look at it. So this table now that you're seeing has 10 million records. Okay, you can see that it is not sorted. You can see that it's not sorted. So because I want to save this table to use it you can see that it's not sorted. It's not sorted. So data is just put in there anyhow. It's not sorted. Yep, so if I come here now I want to say select star into dbo.phonebook. I want to save it somewhere. I don't want any issue. Phonebook 3 from dbo.phonebook2. You can drag this one here like that. So, yep, that's this guy. So it's going to create a new table called dbo.phonebook3 and populate that record. So let's save those data there. So now this is running. It's going to copy. I want us to save that data there so that if we now create index on phonebook 2, we still know that we have 10 million data somewhere that we have saved that we don't want to. Okay, good. You see it here, 10 million rows was affected. So if you refresh your table now, if you refresh this, you're going to see the new table is there. So that's another way you can create a table by using what we call select star into. Good. Now that we have our table saved there, let's go and deal with this heap table. I'm going to close this guy. And we'll come back here. Good. Now, so the data is not sorted as we can see. If you look at that, table 2, if you query it now, you see that the data is not sorted. Look at it, it's not sorted. I already showed you. We can create multiple non-clustered index on last name. Now, if you see now, if we now go and create, hey, want to create, a non-clustered index on phone here. That second creation of an index. Where's the first creation of an index? Sorry, I jumped. So we'll create a non-first. So we'll create a non. Yes, I remember now. We wanted to create. So I'm going to create a non-clustered index first of all. The first one, we're going to create it on that table called phonebook 2. If you highlight your script and you, oh, what's going on? It's still running. What is that? Did I execute any query without knowing? Answer that. Yeah. I don't know what I was doing, but I hope I wasn't running any query anyway. Let me see. I hope no data is. Okay, that's my data that I saved. I hope no index has come in here yet. Good, that's my heap table. Good. So I'm working on phonebook 2, which is my second table that we want to use for our non-clustered index demo. So we highlight all of this and we execute. Good. It has created our non-clustered index, the first one. Remember that we said a table can have more than one. What's happening? Why is it not showing me? More than one non-clustered index. Where's my index now? It's still not showing me. Use index DB. Yes, go create non-clustered index. It's supposed to show me now. Refresh. Go to tables, open DBO2, go to indexes. What happened? Create non-clustered index. Execute. Oh my goodness. On phonebook. So it went to create that non-clustered index on that phonebook. Is we need to watch. Can you see that? You want to create it here. Please don't be afraid of error. I delete that because that's not where I wanted it to create. I'm working with the second one. Okay. I'm working with phonebook 2. So this is supposed to be phonebook 2. That's where my error came from. Good. So you see now that the error has got, the red mark has gone. You're working with phone book 2, so you must name this phone book 2, because that's where you're creating the non-clustered index on. So now, okay, execute. Good. Because I was wondering, why did it create it so quickly? Remember that I said a non-clustered index would create additional pages. Look at the time it's taking us to create a non-clustered index for a table of 10 million rows. It's almost getting to 30 seconds. It has not created it. So you can see the value now because it's creating additional pages. And even if it's a clustered index we are creating, boom, it's creating it based on the key value that we selected to create it on. It will have finished creating it. So you have to be patient because it's 10 million rows you are creating a clustered index, a non-clustered index on. Now you can imagine if you are creating multiple non-clustered indexes on a table with 10 million rows. So you can see the difference now. You can begin to appreciate how it's working now. So I'm just going to pause the video and I'll come back when it's done. Oh, good. Oh, good. I didn't go. So it took about 1 minute, 8 seconds. Look at the right bottom of the screen. 1 minute, 8 seconds to create 10 million, to create a clustered index on 10 million rows of record based on my system now. So now, if you come here, refresh this non-clustered index, refresh, you would see it here. Good, it's there. So now let's also select and see. You will notice that despite the fact that we created a non-clustered index, watch this, the records are still not sorted. And I told you that you can create more than one non-clustered indexes. To prove that to you, are going to create another one. But this time around, it will be on last name. The first one we create is on first name, phone book 2. So this one, we're going to create another one on phone book 2. Don't forget to put it there and put here 2. Good. All right, so I'm going to come there, create another clustered index. Oh, what is going on? What? Oh God, did I hit enter? What query am I executing? I'm going to stop that. My system is so sensitive. Pass that query, good, and execute it. So I'm creating my second non-clustered index. Let's see how long it will take to create the second one. The other time it took us 1 minute, 8 seconds. Guys, I hope you're enjoying the class. And if it goes beyond 1 minute to create the second non-clustered index, I am going to pause the video. Okay. 33 seconds. So you see, that's the last script we're running. Go, good. The last script on clustered and non-clustered index. Before I show you the little things I talked about in the notes. So we're almost done, guys. Please make sure you watch this video over and over again. It is a good foundation if you want to understand the concept with creating the concept about clustered and non-clustered index. So we're already in 1 minute. Oh, this time around it passed. So I'm going to pause the video and I'll return when this index is done creating. So this time around, it took us about 1 minute, 32 seconds to create the second index. So the more you create an index, the more you're taking space. So open that index, you see now, that means a table can have more than one non-clustered indexes. Let me show you. AdventureWorks, you have AdventureWorks. If you go there, you go to any table, you open tables, you check any table. Let's use human resource.employee, open the indexes. What do you see here? You would see one clustered index and so many non-clustered indexes. You see that? Just only one clustered index. So That is to prove the theory that we told you earlier on. Good. So now you can see the table has more than one non-clustered index. So that means you can actually create more than one non-clustered index. So now let's see this. Select. Let's see if the data will still be sorted. In spite of the fact that we have two non-clustered indexes here, look at that. It's not sorted. It's not sorted. Can you see that? So this select star is actually going to go and select more than 1 million record and all of that. So it's taking time. So I'm going to pause it. This is just showing you that it's not sorted. So the last part of the demo that I want to show you is I spoke to you about estimated execution plan, actual execution plan, and the third one we spoke about was live query statistics. If you are running SQL Server, that is from 2016, live query statistics. So if you follow my mouse and you come here, you see where you have execute, you come to this side. When you come here, this is what would display the estimated execution plan. So now, in this our table that we have a non-clustered index, so let's just write a simple query. Now, we don't know how many people's name is Angela, or let's say, let's look for a name here and say Anthony. I don't know how many Anthony that we have here. You say select star from this table where last name equals to, okay, do we search? Where first name, let's just, okay, yeah, where last name is L name, sorry. That's how the column is. It's equal to, let's use, now let me highlight this and comment them out. If you want to comment multiple things out, you highlight, you come up here, you see this thing here? You click on this thing like this, maybe to highlight them so that you don't get wrong. So where last name equals to, let me look for something here. Let's say I picked Anthony. Yeah, Anthony is a popular name. So let's use Anthony. Anthony. Good. Now, if I want to use the estimated execution plan, you will highlight it. Remember I said estimated execution plan. The moment you highlight it and you hit this guy, look at this. It's generate the query optimizer now based on statistics is generating. Now look at it, has generated what we call an execution plan for us. This is what you call an execution plan, an estimated execution plan. See, SQL Server is giving us an estimate. By the way, it's a very wrong practice to use select star. You must always, it's good practice to select by the columns. So try to avoid select star as much as possible, please. I just have to say this there, okay? But now look at what is this? Now look at this. If you look at the execution plan, I said you can read this is a very simple execution plan because it's a simple query and writing. By the time you start having union, join, and all of those things, you see very large execution plan. Now, it's saying that, hey, look at, there's a missing index. If you create a non-clustered index on this table and you include some columns like the phone book ID, blah, 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 phone book ID. If you right click here, if you right click this and you say missing index details, it's going to show you what it's trying to say. It's saying that, hey, there's some, SQL Server is saying that Query Optimizer generated execution plan has suggested that if you create a non-clustered index on these columns, say on, this is what they call included columns. Phone book, you now put, you see that if you include phone book, first name, and phone, you're creating one non-clustered index, but including the 3 columns, that it can actually improve your query by 98%. The time it will take you to retrieve that data will be like, it can improve the cost by 98%. That's what it's simply saying. from the execution plan. Where is our execution plan? Good. Okay, you can right click this guy. Let me right click this guy. You come here, you say new vertical group. It's going to split your so that we can see what we're doing. Split it into two. So it says that, hey, SQL Server, this simple select star that you are doing, even though there's a where clause, it is doing what we call a table scan, and that is a bad. We don't want to see a table scan. Well, a table scan may not really be bad, depending on what you're trying to query. But we always like to see maybe an index seek, or a seek is always better than a scan. So, but based on this simple query that I'm writing, that we just try to generate like this, because I wanted to show you execution plan. So SQL Server suggested that, hey, there's a missing index. So if you now go and create this index, okay, you give it a name, maybe just give it one name, and you create that index, okay, on this phone book, and you run that query again, it can improve it. So we're actually not tuning query today. I would have done that for you, but that will be for next class. So, or someone else may likely take that. So now, that is to show you the estimated execution plan. It shows you the plan. We have not run this query yet, but it's showing us the plan. But there is something that I did not talk to you about. Let me see. I don't want this recording to be too long. It's called physical read and logical read. 1 second, I need to check the time of this recording. I don't want it to be. Okay, let me just be clear. Physical and logical read. Physical reads and logical reads. Now, physical, the name is the spelling. Anyway, physical read and logical read. So, I mean, it's something that you can go make more research in, but I mean, it's very, very important for you to know what a physical read is and what a logical read is, because it's very, very important the way your data is being retrieved, the way your query is optimized. Okay. So it's always better to know that the execution plan always use that too. The actual plan shows what actually happened when the query was executed. If you set your statistics IO on, this is going to display what we call the physical and logical read. Anytime you set your statistics IO on, whenever you set statistics IO on, it is going to display, this will display the physical and logical reads. So another assignment for you: what is physical read? What is logical read? So make sure you do your research on that. But one of them is actually quite straightforward. One of them means that your SQL Server is going to the disk to go and read data. It's doing a lot of physical read. The other one is reading from the cache. The logical read is reading from the cache. Best practice says that it's better for SQL Server to be reading. Anytime you're writing query, SQL Server will allocate memory for that query that is being run at that particular time. So if it is doing a lot of physical read, that means SQL Server is doing a lot of work to go and read the data straight from the disk, and that is not too good for your performance. So your logical read should be as low as possible as well. That would also help you know that, hey, this query I'm running is very good. The moment you set your statistics IO on, it's going to show you, it will display that for you. Okay, it's going to show you, hey, this is the physical read, it's doing this, the logical read. And you can see that when you introduce an index, it can change, different things can happen. So that's just a high level, but I expect you to go, check more on that. Okay. Okay. So now whenever you set your statistics IO on, I've told you that already, okay, good. So we're going to run another query. But before then, I was showing you the estimated plan, right? You can just say set statistics IO on. Always remember to turn it off as well. Execute. So I've set that on. So now if I run this query again and I do my the execution plan, okay, good. It's still showing me the same thing. So if I execute, so it's going to show me if you go to messages, you see this? So it's showing me that, hey, how many rows were affected? So how many people has that last name that is Anthony? Look at this. So we have so many people that have last name that is Anthony. About, it's going to show you more details, about 1,274 rows. You see it? The scan count is 1. It did what we call, look at the logical reads. 58,000 logical reads. Okay, this is not too good. And a physical read, it did 15 physical read. If you set statistics, there's one called statistics IO on. There's another one called statistics time on. It will show you the time it took to run this query. I'll do that for you next time. I mean, look at the read ahead. It reads 39,100. I mean, I don't want to go deep into details. Today was just a high-level introduction. So that is how the estimated execution plan works. But if you want to see your actual execution plan, if you highlight this guy and you select this actual execution plan like this and you execute, so it's going to show you execution plan after. Look at that. It is now showing you after. Can you see that? It's still doing a table scan, and of course the same suggestion. And how many logical reads? It's still doing 58 other logical reads. So if I come here now and I remove this, I say select, let me select by the column. What are those columns that we have there? Select first name, last name, and phone, whatever, phone ID, phone book ID from this guy. So now let's see what this is going to do for us. Okay, we still set our statistics IO on. You can see this. So if I do, let me first of all find what is the estimated. So it's still doing a table scan. Can you see this? It's still doing a table scan. And if I set statistics, time on. I want to see the time it will take us to run that query. Even with that, so run this now, execute. So I've set statistics time on, good. So now let me go and run. I have two things that are on now. So let me run this query and let's see the time that it will take. So I'm going to use actual execution plan. Okay, this time around, let me use live query statistics. You're going to see it running it live. Watch this, guys. You select that and you execute. See live query statistics. Look at this. Look at this. Can you see that? It's showing you live. So SQL Server did a table scan, but all this thing was showing live. I clicked on this third one, this one. So now let's see, this is the live query statistics here. It's showing you this. So let's see the execution plan, the same thing. So look at that. It was still doing a table scan, scanning that for us, even though we have, what do they call it? Non-clustered index in there. And then see the messages. How long did it take us to run this query? Let's see. So 2 rows affected. Logical reads. Where is it? So it still did 5309 logical read. And see the time it used in the CPU to run that query. So I mean, this will just help you look at how is SQL Server. These are some things you must know behind the scene. So I have covered how to use actual execution plan, estimated, and I've shown you live query statistics. But the wrap up would be, how does an index improve the query, the running of a query? So I'll go to the third table now and do that demo for you. Okay, I'll go to the third table now and do that for you so that you can see, you can appreciate, because that's a heap table. It doesn't have any index, okay? So now let's say, let me still copy this query and let me run it on the third table, copy. We still have all those things on, guys, don't forget. But that table is a heap table. I'm querying a heap table now. Yep, select, yeah. So pass this guy. The table has the same information inside. No. Execute. So look at this. Look at the live query statistics. Look at this. It's in a table scan too. Okay, scanned. Scan. Let me look at the message. How many logical reads? The same logical read as that guy on that table. So that means even this one with this index here, good. You can see that, guys. So this is how the live query statistics will be showing you how, and it's telling you that there's a missing index. It says we should go and create a non-clustered index that will improve our query. I know somebody will be curious that, hey, go create it, but I'm querying last name, Anthony, or whatever. So if you want to improve this query, you can either create this index, and when you create this index, you run that query again, because I'm actually querying 3 colon here. You see that I'm querying 3 columns. So if I go and put this on now, and then I write this query again, or I try to streamline, it may improve it depending on what we're doing. But today's class is not to do query tuning, of which I will do it another time, but I don't want this video to be too long. I hope you are able to get the concept of an execution plan. SQL Server, the query optimizer, use statistics to generate an optimal execution plan, okay? To generate an execution plan. So your execution plan can be either an estimated or an actual or a live query statistics. Look at it here. Look at my mouse. Estimated execution plan, actual or live query statistics. So that's where to locate them. So please, this is just an introduction on index, clustered and non-clustered index, and how you can use indexes to improve your query to make it run faster. I think I'm still yet to show you that. I almost forgot that one. So now there is no index on this table, okay? But now let me go to this particular, you may want to ask a question that, okay, how come this table that does not have an index, how long did it take us to run? It took us 1,250 times. Look at the elapsed time, 3 milliseconds. So let me run the one that has the non-clustered index. Let's see how long it will take to run. Let's see if that index actually, this one is live query statistics I highlighted, is still using that. What's the time? Can you see this, guys? Can you see that the elapsed time is shorter, 3 milliseconds? So an index actually help you. This one has a non-clustered index. As you can see, DBO Phone Book 2 has a 2 non-clustered index. This one is a heap table, no index. So I'm writing the same query. Let me bring it down so you don't get confused. I'm going to copy that same query. I'm going to put it here. So now I'm working on these two tables. One is a heap table. This is query the heap table. Heap table. Query the table with index. So you can see that index help you retrieve data faster, more faster and more efficient. So if I run this two like this, execute, and it's going to, I took that risk. Let's see. So good. I ran the two, so for us to be able to compare. Now the one under, it's look at that. Okay, I can see some things here, but let me go into the message and find out how SQL Server did this. So we start from the first, the one with the index. It took it 7 minutes to run and see the CPU time. The same number of rows was affected, but the one, the heap table, what happened? Elapsed time 3. Good, good. Now look at this. The elapsed time it took is what? 0. The one with the index. But if you come down here, SQL Server execution time, look at it there, 1000 rows. So this is from phone book 1. See the logical read. The logical read is that, physical read is 0. Then here, look at the physical read that is doing with a table without index. Is doing, look at the physical read with a table without index. The same number of rows, but phone book 3. The same logical read, but the physical read. So this is a poor performance because it's doing a lot of physical read. It's reading this. Look at that. And the elapsed time is this. Look at the elapsed time because it doesn't have an index. 4,175 milliseconds. So therefore, we can conclude by this that an index helps you retrieve data more faster and more efficient. Thank you.